In this video, we will be addressing the important phenomenon of gravity. So what is it? What is gravity exactly? Gravity is the most important force in the universe. It is what binds the planets in our solar system with the sun and the moon to Earth. It is also involved in the creation of tides which happen as a result of the rotation of Earth and the gravitational effects of the moon and sun. It is because of gravity that massive objects attract each other. Did you know that because Mars has a lower gravity than Earth, a person weighing 200 pounds on Earth would only weigh 76 on Mars? That also racing cars and roller coasters are made possible because of gravity? And that the higher something is, the greater its gravitational potential energy? In the Middle Ages, weapons called trebuchets were used to take advantage of this principle, using mechanical advantage and the gravitational potential energy of a counterweight to hurl rocks and other projectiles at or over walls. Today, we use the gravitational potential of water to create hydroelectricity. The free-fall motion can help add to our understanding of gravity. It is a special type of motion in which the only force acting upon an object is gravity. Objects that are said to be undergoing free fall are not encountering a significant force of air resistance. They are falling under the sole influence of gravity. Under such conditions, all objects will fall at the same rate of acceleration regardless of their mass. But why, you ask? Let's look at this video of the feather and the stone, then try to understand how gravity works.
So objects would fall at the same rate, despite a difference in weight. Professor Brian Cox recently used the vacuum chamber to test the gravity theories postulated by Galileo and Sir Isaac Newton.
Let's start by looking at the different contributions of scientists on the matter. First was Aristotle. In the 4th century BC, Greek philosopher Aristotle believed that heavy objects are not attracted to the earth by an external force of gravity, but tend toward the center of the universe because of an inner heaviness. He believed that there is no effect without cause, and that the cause of downward motion of heavy bodies such as the element of earth was related to their nature, which caused them to move toward the center, and that the cause of upward motion of light bodies such as the element fire was related to their nature, which caused them to move toward the inner surface of the sphere of the moon. He said that objects with larger masses will fall faster, but never actually tested his theory. Then came Galileo. During the 17th century, Galileo found that, counter to Aristotle's teachings, all objects accelerated equally when falling. One of his famous experiments is perching atop the Leaning Tower of Pisa and dropping cannonballs of different weights that all objects fall at the same rate. It's the kind of story that's easy to imagine, easy to remember, but whether he ever performed the experiment at the tower is debatable. Still, Galileo did perform some ingenious experiments on gravity while at Pisa. In fact, for his approach to science, that of using math and analyzing the results of experiments, he is credited with initiating the modern style of scientific research. Next came Newton's contribution. The notion of gravity was first introduced by Newton in the 1660s. Isaac Newton's theory on gravity were inspired by seeing an apple fall from a tree. He invented a way to measure its strength and magnitude between bodies, but he could not provide the logical explanation of how it acts. Newton subscribed to the opinion that gravity is instantaneous. Lastly came Einstein, the rebel. In the early 90s, Einstein introduced his theory of relativity, in which he was able to describe what gravity is and how it works. He put forth bold predictions of his theory, such as the bending of light by gravity, that came true in a few years. Einstein's work on gravity and spacetime is what made him the most celebrated scientist of all time. He proved Newton wrong in the idea of the speed of gravity, and he was able to explain how the attraction happened by explaining that gravity is nothing but a curvature and that the light will bend near massive stars behind the sun. He introduced the idea of gravity as curved spacetime. He basically believed that matter tells spacetime how to curve, and curved spacetime tells matter how to move. But so what then? Why is all of this even important to us? How does gravity benefit us? Well, because of it, we learned how to send satellites around the Earth. We also learned how to get to the moon. And we managed to come up with many technological inventions that wouldn't be very accurate without our current understanding of gravity. One important example is the GPS we use to get around. Without our understanding of gravity, the calculations would be off and they wouldn't be very accurate.